5, 4, engine ignition, 2, 1, 0. Ready, and liftoff. As the countdown to Mars continues, the perseverance of humanity launching the next generation of robotic explorers to the Red Planet.
The Perseverance mission is to investigate astrobiology on Mars, and in particular, to address the question of whether life ever existed on Mars.
During this broadcast, you'll see a different visualization called Ranger, and it's based on the real communication the team in Mission Control receives from Perseverance in near real time.
Perseverance sends direct-to-Earth X-band tones, each of which provides us with indications of critical entry, descent, and landing events. During entry, descent, and landing, we have 2 Mars orbiters listening for the ultra-high frequency, or UHF, signals from Perseverance. These orbiters relay these signals to Deep Space Network stations on Earth, Madrid in Spain, and Goldstone in California. The Mars Reconnaissance Orbiter, or MRO, has reconfigured its software to perform a type of relay called bent pipe. This will provide us with near real-time telemetry during entry, descent, and landing. We have coverage from the Mars Reconnaissance Orbiter from just before entry to a few minutes after landing. The Mars Atmosphere and Volatile Evolution spacecraft, or MAVEN, is recording these UHF signals and will be relaying that recording hours after landing. MAVEN will be covering us from around the time of cruise stage separation until a few minutes after landing. It's important to note that while unexpected, we could lose our communication links and still land safely.
It takes about 7 minutes to get from the top of the atmosphere of Mars to the ground safely.
There's a lot of work on the line.
For entry, we get rid of really the spacecraft part of the rover that's been supporting us.
We come 12 to 13,000 miles per hour.
And the heat shield is what dissipates all that initial energy through friction.
The vehicle will continue actually flying itself through the atmosphere. It's sort of like a transforming vehicle that went from a spacecraft, and now it's kind of like an aircraft actively guiding itself. It's the biggest supersonic parachute we've ever sent to another planet. It's critical for slowing down the vehicle.
You know, Mars is the closest place that we can reach with robotic exploration that we think had a really good chance of having ancient life.
The Perseverance rover will land at a location called Jezero Crater. Jezero Crater is a very interesting place. It's a crater that once held a lake.
There are a lot of craters on the surface of Mars that could have once hosted ancient lakes, but not every crater that we think had a lake actually preserves evidence that that lake was there.
It had an inflow channel and it had an outflow channel. That means it was filled. The crater was filled with water.
In Jezero, we have probably one of the most beautifully preserved delta deposits on Mars in that
Descending on the parachute, it will actually be taking images of the surface of Mars and determining where to go based on what it sees. Having this new technology really allows Perseverance to land amongst the rocks and the crater.
Once Perseverance has figured out where she is, we jettison the back shell and parachute and light up our rockets. Those rockets help us steer to a safe landing spot that's nearby.
That descent stage takes us all the way down to about 20 meters off the ground.
That's when we start the sky cannon. Once the rover has hit the ground, the descent stage will cut loose from the rover and fly away to a safe distance. Surviving that 7 minutes is really just the beginning for Perseverance. Its job, right, being the first leg of sample return, to go look for those signs of past life on Mars.
I have to admit, I am quite anxious, but very hopeful that this machine is going to do what we asked it to do.
We're seeing the heartbeat tones.
Okay, that means that there's no more ones and zeros coming. It's just the vehicle telling us it's still alive.
We're continuing to receive tones from Perseverance, standing by for cruise stage separation. We have indication that cruise stage separation has been confirmed by the spacecraft. At this point, the spacecraft is trying to stop its spin from the cruise 2 revolutions per minute down to 0.
MROs are in receive mode.
We have confirmation that The Mars Reconnaissance Orbiter is now relaying data from Perseverance. We're about 30 seconds from entry interface, 5.3 kilometers per second, and an altitude of 150 kilometers from the surface of Mars. The spacecraft will jettison the entry balance masses in preparation for parachute deploy and to roll over to give the radar a better look at the ground. To subsonic speeds, and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second and an altitude of about 9.5 kilometers above the surface. Perseverance now has radar lock on the ground. Current velocity is about 100 meters per second. 6 of confirmation that the lander vision system has produced a valid solution and part of terrain relative navigation. Current velocity is 83 meters per second at about 2.6 kilometers from the surface of Mars. We have confirmation that the back shell has separated. We are currently performing the divert maneuver. We have completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars. Perseverance safely on the surface of Mars, ready to begin seeking the sands of past life.